Okay, here is the answer to the topic 2 test, question 10, the question about curling. We're given a speed time graph and we're asked to determine the coefficient of dynamic friction between the stone and the ice during the last 14 seconds of the stone's motion. So to work out the coefficient of friction, we use the formula F equals mu times R. So the coefficient of friction is mu, and the force of the friction will be F, and the R will be the resultant force on the of the stone. So if we draw a picture of our stone, there's a couple of forces acting on it. We've got the weight acting downwards, which is mg, and we've also got the resultant force, or normal force, which is acting upwards, and they're going to be equal and opposite. Okay, so that's going to be R. So we've got a little bit of our puzzle here. Okay, so we've got, we're trying to find out mu, and we know that R is going to be equal to mg. Okay, now we have to work out this friction force, and if we have force, that is going to equal the mass times acceleration. So the mass we're going to have here, so this is going to be ma, but so those two will cancel out eventually, so we don't need to know m, but we do need to know a, and a is going to equal the change in velocity of the stone divided by the time it takes to travel. Now we've got v, because v here would be 0, so v equals 0, because in the question it says that it begins, when it begins to its resting velocity, so that's okay, so we've got 0, but what we need to work out is what the u is. And we can do that because they've given us the distance that it travels. And because this is a speed time graph, the area under the graph equals the distance or the displacement. And that we know equals 29.98. And we can then work out, we've got this one here, we've got this one here at 17.5 seconds, so that's the base, yeah, and this is the height. So the area of this triangle is base height divided 2. So if we don't know what the h is, that's what the initial velocity is, so we'll solve for that. So if we want the height, so the height, which is v, is going to equal the area, which is 29.98, and we're going to multiply it by 2 and divide it by the base, which is 17.5. So if we plug that into our calculator, so that's 29.8 times 2, 17.5, the initial velocity is going to be 3.1. So I'm just going to put that in here, so 3.41, sorry, over the time it takes, and it's not the full time this time, I'm only interested in this last 14 seconds, so we're going to do it by 14. and that's going to give us 0.243 meters per second. Okay, so now I've got our acceleration, so we can plug it in over here. So let's isolate the mu because that's what we want to work out. So the mu is going to equal the ma divided by the mg, and they're going to cancel out because the mass doesn't change. So this is going to be 0.243, and I'm going to divide it by the gravity, so 9.81, and that's going to give me an answer of 0.0248. And that is my coefficient of dynamic